All right, this video is going to talk about some special products of polynomials or special sort of answer, special patterns that we can get. We already know how to add, subtract, and multiply polynomials, but sometimes when we do this, there's a slightly faster method if we notice a good pattern. So let's try these couple up top. You'll notice we've got a bunch of binomials. So I'm going to go ahead and use the FOIL method. If you remember, first, outside, inside, and last. It's really just distributing. So again, if you're a bigger fan of distributing, go ahead and do it that way. But let's go ahead and watch what happens when we actually FOIL together or distribute these polynomials. So I'm going to take x times x and x times 4. So I'm going to get an x times x is x squared, and x times 4 is 4x, right? That was my first and my outside. Then we do the inside for a minus 4x, and negative 4 times 4 in the last is going to be a negative 16. If we add the two middle terms together, now notice what happens. 4 plus negative 4 is actually 0x. So those two terms are actually going to cancel one another away. And we really only get x squared minus 16 when we're done. Now that might seem kind of weird, and it should, but really it's very helpful. And knowing why that happened is really the most helpful part. Notice that up top we had x minus 4 and x plus 4. They're really almost the same statements. There's just a minus and a plus that are different, right? But we had 4s and we had x's. So because of the way those lined up, those two middle terms disappeared, and we actually got a simpler statement when we were done, x squared minus 16. Let's see if that doesn't happen over here as well. We've got a 5x and another 5x. So notice that first term just ends up being sort of squared, right? 5 squared and x squared. But then I'm going to get a minus 10x and a plus 10x because we had 2's and 5's sort of together, right? We had a 5x and a 5x, a 2 and a 2, but one was plus, one was minus. We're going to get that minus 10 plus 10. And then finally, don't forget the last term, we get a minus 4. But if we combine our like terms then, 25x squared, again, those minus 10 plus 10 terms, those x to the first terms, disappear. And we really only get those two sort of perfect square terms, right? 25 and negative 4. The 4 at least being a perfect square, I guess, not with the minus. But we get those two terms when we're done. So again, we call this the sum and difference pattern. We have the sum of two terms and the difference, right, subtraction, right, sum meaning addition, difference meaning subtraction. But notice how they both have an a and a b. And if that's the case, we can sort of shortcut that. We don't need a middle term, but instead we're just going to get a squared and b squared. And notice how we're going to be a difference when we finish. Again, do you need to memorize these patterns? Not necessarily. We could just FOIL them out and get those answers, but it's kind of nice if we already know why that middle term is going to disappear on us. Similarly, what if we have something like x plus 4 squared? Well, this is really the statement x plus 4 times x plus 4. It's that statement times itself. So maybe there's a special pattern here as well. Now it's just both of them are a sum, although notice on the next one they'll both be a difference. Again, still the same statement twice. But what if we don't mix a plus and a minus? What happens to that middle term for this? Because notice we're still going to get x squared. And we're still in the last term going to get that 16, right? But this time in the outside, we get a 4x. And on the inside, I also got 4x. So it's not that they're going to cancel one another, right? They don't add and subtract to disappear. What happens is we actually double. 4x plus 4x is 8x plus 16. Let's see if the same thing didn't happen in the middle one here. X times x would have been x squared. Then we get a minus 6x. Another minus 6x. And a plus 36 here, so a perfect square on the end. And again, we get our x squared. We double the middle, right, instead of disappearing. And then we get 36 when we're done. Well, let's see if that happens on the last one as well. 3n plus 4, right? And 3n plus 4 is going to make 9n squared plus 12n. 4 times 3 is again plus 12n. And finally, 4 times 4 would be 16. So notice again, we get perfect squares, 9n squared, and 16 on the ends. But then in the middle, instead of 12n, we've just doubled to 24n. So on the first screen, when it was a sum and a difference, that middle term always canceled. But on this screen, that middle term always doubles. And let's look over here to the right to kind of see why that happens. A plus b squared, right, is going to be an a squared up top here. We're also going to have a b squared. So there's that first and last term, right, those perfect squares. But notice, if we multiply sort of that table method, we end up with 2 of the same term here and here. So that's where we got this 2ab in the middle. I'm going to have a squared, right, that first term, but then I'm going to get ab and ab. I'm always going to double 2, right, ab's. Then we'll finish with, again, b squared. Well, let's see, the same thing happened when we did subtraction, right? So again, we'd have a squared, only this time it's a negative b, so again, negative ab. These would have basically become minus signs in front of here, right? We could put a couple of minus signs. Negative ab and negative ab makes negative 2ab, much like we had that negative 12 over here, right, on the left. And then we also still end up with b squared. Remember, even though that would have been negative b's, right, even though these were a negative b here and a negative b there, negative times negative still ends up being positive b squared when we finish. So again, that's called the square of a binomial pattern, or sometimes the perfect square pattern. Okay? So hopefully that method will help us out as well. Now, we can sometimes see this a little bit in science class as well. If you're familiar with Punnett squares, we'll talk about this very quickly. Basically, if an animal, like a ball python here is our example, has some genes, right? We have dominant genes and we have recessive genes. So again, the N is for normal coloring and A would be for like an albino snake. Well, if mom has one gene of both and dad has one gene of both, basically N times N is N squared. And an NN, right, would be a definite colored snake. But again, N times A and N times A, we'll end up with a couple of those. We just looked at that pattern. Well, N is the dominant, so NA would also have normal coloring, right? A normally colored snake. But if A is times A, we do have one possibility, right, out of the 4 that we have an albino snake, right? There's no sort of normal coloring gene there. It's definitely going to be an albino snake. Well, and they realize those 4 terms essentially just are foiling this together, right? N squared, N times A, another N times A, and A times A. We're just getting that binomial pattern, right? That perfect square pattern. And one out of those 4 things, right, probability-wise, one out of the 4 chances is that we'll get an albino snake. Now we can play around with that a little bit. What if, again, we've got one parent that has both genes and one parent is already an albino snake? Well, in that case, we're going to get NA. We'll have another A squared here, another NA, and an A squared. Or basically, we could do that mathematically, right? Foiling out NA and AA. But in the end, that means we have even more chances, right? A times A, 2 out of the 4, or 1 out of 2, right? 2 out of the 4 chances. So there's a half probability, 50% probability with an albino snake and a sort of mixed, normal color snake, right? That we'll end up with an albino snake. Greater chance there. So again, just a real world application of this sort of foiling idea, right? These perfect square patterns. Biggest idea though, make sure you kind of get familiar with these 2 perfect square patterns. Remember that there's 2 of that middle term in the middle when we're done, right? So I could say sort of A squared, A times B times 2, and b squared. A squared, a times negative b times 2, and negative b squared is b squared when we're done. Again, that's a great way to handle that perfect square pattern. And don't forget the sum and difference pattern as well. If you have a positive and a negative, now we don't even end up with a middle term because, again, they cancel to 0. Talk to your teacher if you have any questions. Otherwise, have a great day.